to welcome you to the Dallas Independent School District STEM Environmental Education Center virtual field trip. We want to say a very special welcome to David G. Burnett, Wilmer Hutchins, Clara Oliver, Arthur Kramer, Dave Zavala, Martin Weiss, and Geneva Heights, all of the Dallas ISD. Thank you so much for joining us. Teachers, if you are watching and you are not signed up, please go to www.tiny.cc/3-5 registration. Sign up for us, please. We would appreciate it. The program today is Earth's Changes. During this virtual field trip, students will explore the processes that led to the formation of sedimentary rocks and fossil fuels. Students will also recognize how landforms are the result of changes to the Earth's surface by wind, water, and ice. Formation of sedimentary rocks and fossil fuels will be taught by Mr. Dominguez. Mr. Monroe will cover deltas. Ms. Schramm will tell you about canyons, and Ms. Ramirez will cover sand dunes. Students, you cannot ask us a question during this program, but you can go to www.tiny.cc/questions-answer and fill out a form and send it in. And we would appreciate it. Now I'm going to stop sharing my screen. And Mr. Dominguez is going to tell you about sedimentary rocks and fossil fuels.
Hey guys, in this portion of your virtual field trip, we are going to be talking about rocks. So these things right here. Now, you guys may already know this, but there's 3 different types of rock. There's igneous rock, metamorphic rock, and sedimentary rock. Today, we are going to focus on one type of rock, sedimentary. We're going to be talking about the processes that lead to sedimentary rock formation, and those include erosion, weathering, and deposition. We're also going to be talking about fossil fuels, and you guys may already know that fossil fuels are a natural resource that comes from the ground. But how are fossil fuels formed? Today, we're going to answer that question, and hopefully you guys get a better understanding of how organisms that lived millions of years ago end up in your gas tank. So let's get started with this presentation, guys. I hope you guys enjoy it. All right, guys, so there's a couple of things that I want to talk about before we get to sedimentary rock formation. And that is the formation of the other 2 types of rock, because it's important to know how those rocks are formed in order to understand how sedimentary rock is formed. And I have some samples here of all 3 types of rock. Let's start off with igneous rock. And igneous rock is formed when lava cools down. So the word igneous means from fire. So this is pumice, and pumice is a type of igneous rock. Here we have granite, another form of igneous rock. And then we have metamorphic rock, and this is marble. And metamorphic rock is formed when you expose a rock, such as this sedimentary rock, to an immense amount of heat and pressure. So the word metamorphic means to transform. So you are transforming a rock like this shale into metamorphic rock by exposing it to tons of heat and tons of pressure. Now, how is sedimentary rock formed? Now, that's the question for today, or at least this portion of your field trip. So the word sedimentary, and you might have guessed this, means that the rock is formed from sediment. And what is sediment? Well, sediment is just broken down rock and some organic matter as well. So this is sediment. And this is very fine sediment. Some of the pieces are actually pretty big. So how does this sediment form? How is this sediment created? Well, it's created through 2 processes, and that's weathering and erosion. Now, there's different types of weathering. There's biological weathering, there's physical weathering, and there's also chemical weathering. And the names are pretty self-explanatory. You get physical weathering through something like this. So let me see if I can chip. There we go. So I chipped a piece off of this rock. That's considered physical weathering. So you may have that happen when 2 rocks rub against each other. Chemical weathering could be acid rain falling on this rock and wearing it down to finer particles. And some bacteria may break down rock as well. So that's biological weathering. And erosion, you get erosion through wind, water. So those two things will wear down rock as well. And eventually you get something called sediment. And this sediment is not going to stay in one spot. Erosion is going to move it. And what's going to happen is you're going to get deposits of sediment starting to layer on top of each other. And eventually you're going to get so much sediment layering on top of each other that the pressure is going to bring these particles back together to form a new different type of rock called sedimentary rock. And what I have here is one of my favorite examples of sedimentary rock. This is sandstone. And why do I love sandstone so much? Well, it's because you can actually see that process in action. You can actually see the layers of sediment that have built up over time. And remember, this takes millions of years. So this is a beautiful example of that process in action. Now, I want to show you guys a really fun way of doing this in your classroom or at home. So check this out. So a really easy way to visualize the formation of sedimentary rock is to get yourself some starburst. And all of these different colored starburst represent a different particle of sediment that has been eroded or weathered away from some other rock. Now, what happens over time, and when I say time, I mean millions of years, this gets carried, and what happens is the sediment starts piling on top of each other. All the sediment particles start to compress one another. And we don't have enough starburst or enough time to show that on its own. So we're going to use our hands to demonstrate that process of the particles coming together after layering on top of one another for so much time. So all you have to do is squeeze, 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 squeeze. And remember, the squeezing of my hand represents all that time and all that weight of the sediment being compacted into a new sedimentary rock. So here we have it. And this is a really good way to just visualize that process that takes millions of years. So before I let you guys go today, we have to talk about fossil fuels. So what are they? Well, fossil fuels are a natural resource that comes from the ground. So those things include oil, natural gas, and coal. And we need those things at the moment to fuel everything from our cars to our homes and everything in between. But what are fossil fuels? So fossil fuels are the byproduct of the decomposition process of things like plankton and plant life. In fact, plankton decomposes into natural gas and oil, and plant life that decomposed turns into coal. And what happens is, so here's a basic demonstration. So the soda represents the decomposed hydrocarbons. They seep into the ground, and what you end up getting are these pockets of fossil fuels. And that's why we have to dig, and that's why people frack and drill holes into the ground to find those rich pools of hydrocarbons that at the moment are the primary source of our energy. So I hope that you guys learned a little something about sedimentary rock and fossil fuels today. I will see you guys next time for the next virtual field trip. Have a great day.
Thank you, Mr. Dominguez. We did have a question. why only sedimentary rocks have fossil fuels? Why do only sedimentary rocks have fossil fuels? Sedimentary rocks are formed by the deposition of sediments layer by layer, making it easy to contain fossils and fossil fuels. Sedimentary rocks are soft rocks, thus it does not destroy the fossils, and in a longer run, we get the fossil fuels like the coal, petroleum products, which are very important for human life. And now Mr. Monroe is going to tell us about deltas.
Good morning, everyone. My name is Mr. Monroe, and we are going to be looking into a landform called a delta. Now, there are deltas found all over the world in certain places. And we have one that's pretty close to where we live, the region that we live in North America. It is called the Mississippi Delta. Hopefully by the end of my presentation, you guys are going to understand which earth process is the major process that helps form deltas. Also, hopefully, you'll realize that there are some benefits to having deltas around. Well, let's talk about deltas just for a little bit. You know, deltas are a landform that is comprised of sediments found at the mouth of a river. We know that a river has a beginning, and then where it opens up maybe into another body of water, that is called the mouth. Now, a delta can only form when a river channel carries sediment into another body of water. You know, a Greek historian first used the term delta for the Nile River in Egypt. Now, that Nile River had a lot of historical value. It was also a very, very rich farmland. You know, this is because the sediment, the land mass developed at the mouth of that particular river formed a triangle. And that looks like the uppercase Greek letter that represented the word delta. Now, the water current that creates a delta through erosion of the land by its force, also wind, and eventually gravity, help move sediments into a certain area in the form of gravel, sand, silt, and clay. You know, the water slows down when encountering another body of water. And that goes back to the fact that no delta will form unless the flow from the river is going into another body of water. Now, the sediments that are deposited onto a flat area, and that's where they start dropping. The sediments that are deposited in that area are called alluvium. They pile up into several layers called beds. You know, some of the factors that involve the types of sediments that are laid down is the depth of the river, the width of the river, also the velocity of the water current, and that helps determine how big the sediments that are being carried. Now, there are three different types of deltas. For example, the Nile River Delta, it belongs to a group of deltas simply because of its shape, called an arcuate delta. The Mississippi Delta, because of the shape of its delta, is actually referred to as the type that would be called a bird foot. And then the Tiber Delta actually belongs to another group, which is referred to as the cuspid. So there are three different formations of deltas according to the way that they're shaped. Now, let's take, for example, the Mississippi Delta. It's called the bird foot. Well, that bird foot, the area of that delta, believe it or not, it covers 3 million acres. Boy, that's a large piece of land. And it is very fertile. So that is one benefit that benefits the farmers that are able to farm certain parts of that land, okay? Now, the modern Mississippi Delta formed over the last 4,500 years. So it takes a long time for all that sediment, that silt, to build up into what we call a delta. Now, I'm going to use a couple of items to show you the difference between some of the sizes of silt, sediment, and maybe how gravity plays a very big part in how it settles, how those particles are settled to form that delta with the use of gravity. Here I have what we call a sediment table. I shook it up just a minute ago, and I'm going to shake it up again. Listen, if you were with us today, at each one of my lab tables, each student would get one of these, or I would partner you up with the person that's sitting across from you. And we would go through this process. You would probably think, oh, I'm getting good exercise today. I would have you guys shaking this up and down, side to side, really mixing it up good. And we would do it for, maybe somewhere between 5 and 10 minutes. And by the time that we had actually started, some of you would probably be getting tired, like I'm getting tired now. So you probably would have to switch hands or maybe have your partner do some of it too, because we want it to really be mixed up real good. Now it's mixed up pretty good because you can't see any layers. Take into consideration this. Boy, river currents can move very fast, very strong. In fact, they say water and gravity working in concert is the strongest erosion agents on our planet. And when we're using that term erosion, we're talking about the transporting of broken down or loose material from one place to another. It could be soil, it could be sediment, bits and pieces of rock, but it's very hard to tell what's what in this. Now, after it settles, we're going to have layers setting up, because remember what I said? As a river flows down, the current slows down and loses its strength. The larger particles are going to fall first, then the next largest will fall next, and the lighter particles, which is a form of silt, would be the last one, because the water is going to continue to carry those until the current slows to almost a stop. Now, this one has been setting overnight. I shook it up yesterday before I left. Now we can see, if you look real close, hopefully you can see this, the larger particles are down at the bottom. Then we have sand, which is the next largest particle in this sedimentator. And then we have silt, which is the top one. And probably, if I let this set overnight tonight, when I come in tomorrow, this water is going to be clearer and there will be more silt added because there's still silt suspended in the water here. So that's about how it is laid down, okay? Now, also, to show you how they are formed, I'm going to be using a mini stream table. I've created a mound representing, let's say a mountain. And we know that sometimes at the higher elevations, when it rains, we do get a water flow down the side of a mountain. In fact, the Mississippi River is flowing from higher elevation to a lower elevation as it goes through the state of Louisiana. We know that a lot of Louisiana is actually at sea level, and some locations are actually below sea level. So rivers usually, commonly, they flow downhill. And if the decline or the hill is steep, guess what? The current picks up velocity and becomes very strong, carrying a lot of larger pieces of sediment. Now remember, a river will take a lot of the surrounding land. And I can relate this to you. The Red River at one time actually was a very accurate border between the state of Oklahoma, my home state, and the state of Texas. Well, that river's channel changes because of erosion. Sometimes it meanders, it turns, it takes away some of the surrounding bank or surrounding land, and it changes. So we really can't really say that it is actually now today the true border between the state of Oklahoma and the state of Texas. Hopefully you understand that. Well, let's go further. Let me go ahead and pour a little water on this and let's see what happens to my mountain here. See if we can create a delta. Well, we did create a delta. We have a river channel that ran down through here, but that river channel, and this happened very quickly, it created a crevice. In fact, you're going to be learning a little bit more about this type of landform. It's called a canyon as you go further into your virtual field trip today. But the part that we're concerned with is this part here. This represents the delta, okay? It carried some of the surrounding land down and formed this area. And if this was in real life, this would be the area that there would be farmers benefiting from the rich soil that was created by erosion, forming that delta, carrying some of the surrounding land from the riverbanks and surrounding the land as the river passes through it, taking that silt sediment down to where it settled. And boy, would there be some rich crops grown there. Well, listen, we're going to do a little bit of map reading here just for a second, because I want you guys to realize where the Mississippi River Delta is actually located, okay? So bear with me while I share my screen with you. I have a little map we're going to look at. Let me make that a little bit bigger. Okay, right here, we have the state of Oklahoma. And right along here, that's where the Red River is. This is our home state. We're located somewhere in this area in North Texas. If we go over here, this is the Mississippi River. Goes all the way up. That's the Mississippi River. Comes all over there. And just think about it. All that area that the Mississippi River is traveling through, there are some very rich farmlands all the way up to what we call the Midwest, okay? And a lot of that soil is brought down through the Mississippi River, and it's moving all that sediment into the Mississippi River Delta, which is emptying into the Gulf of Mexico. And if you look at the Delta, it's kind of spread out right in here, right? So that's why they call this type of delta a bird foot. It's spread out like a bird foot. Boy, the farmers really benefit from that too. All that rich soil in this area. But listen, guys, I have run out of time, so I'm going to stop sharing my screen with you guys, and I'm going to give it back to Dr. Gorman. So if any of you have any questions, I bet he can answer them for you.
Thank you, Mr. Monroe. And we did have a question. What are some of the more famous deltas? The Nile Delta on the Mediterranean Sea, Mississippi Delta in the Gulf of Mexico, the Yellow River Delta in the Boha Sea, and the Ganges, Brahmaputra Delta in the Bay of Bengal rank among the most famous and the best well known. And now Ms. Ram is going to talk to you about canyons.
Hey friends, it's Miss Ram. So we are talking all about canyon formation. So at the end of my little section, you'll be able to recognize how landforms are formed, such as canyons, as a result of changes to the Earth's surface by wind, water, and ice. So based on Mr. Monroe's presentation, you got a little sneak peek into how canyons are formed. So you probably could guess whether they're created with wind, water, or ice already, but we'll get into it. So first of all, what is a canyon? A canyon is a narrow valley, a narrow valley surrounded by cliffs. So the picture on the left is a picture of the Grand Canyon. And my little hint to you is flowing through is the Colorado River. So how do canyons form? The movement of rivers and the processes of weathering and erosion and tectonic activity create canyons. So what happens is that the water pressure cuts deep into the riverbed, and sediments are carried downstream, making a deep, narrow channel. So you could see again the picture of the Grand Canyon. At one point, the river was level up here, but over time, it was wearing away at that rock until now we have it about a mile deep. So the Grand Canyon is the most well-known canyon in the United States. So located in Arizona, Grand Canyon National Park encompasses 277 miles of the Colorado River. And the Grand Canyon took about 5 to 6 million years to form. And like I said a couple seconds ago, it is a mile deep in some places, but it is also 18 miles wide. Well, up to 18 miles wide. Okay, so 60 million years ago, colliding tectonic plates pushed the Colorado plateau higher in elevation. So those tectonic plates were making a plateau. So plateau is when it goes up and it's flat on the top. So instead of a mountain where it has a peak, it's raised flat land. But now, today, you could see the Colorado River has carved down through the plateau and exposing ancient layers of rock. So that took about, like I said, about 5 to 6 million years, but you can see the big differences of the rocks. So up towards the top, you could see layers of sedimentary rock, you could see the stripes, and different layers have different kinds of fossils and different types of stone that give a geological history of the area. And then towards the bottom, metamorphic and igneous rocks can be found going further back in time. So it's basically like a cross section to see a geological timeline of that area. Here is a famous point of the Grand Canyon. This is Horseshoe Bend. And another famous part of the Grand Canyon is the Grand Canyon Skywalk. So this is actually a man-made feature. It is a bridge that goes kind of in a horseshoe shape out over the canyon and then back in. So you can walk out there, there's glass on the sides, and you can look over and see all the way down. I'm kind of scared of heights, so I don't know if I would be able to handle it, but it is on my bucket list to visit the Grand Canyon, and I think I would have to do it if I was there, but I don't know. Would you guys do it? Woo! It's kind of scary. Okay, so there's a lot of things you can do at the Grand Canyon. You can go hiking. There's a lot of course, photo opportunities. You can go horseback riding. You can go to museums, there's tours, all this sorts of stuff. And obviously it is huge, so there's tons of opportunity to do different activities and everything there. So you might be thinking, yeah, that's great, but that's kind of far away. Well, do we have any canyons in Texas? And the answer is yes. We have the Palo Duro Canyon, and the state park is over here in the little panhandle. So the Palo Duro Canyon is known as the Grand Canyon of Texas. It's the second largest canyon in the country. And like I said, it is right there in the Texas panhandle. So we are all the way over here for reference. And there is the state park. Now, here are some pictures of the Palo Duro Canyon. Now, it is significantly smaller than the Grand Canyon, of course, because the Grand Canyon is huge. So the Palo Duro Canyon is 120 miles long and points up to 800 feet deep. So compared to the mile deep, that's a lot smaller. But it is the second largest in the country, so good for us. It was formed 1 million years ago, and it was formed by the Prairie Dogtown Fork Red River. So one big long name. So Prairie Dogtown Fork Red River. So basically that's just a fork in the river that is one of the main tributaries to the Red River. And of course the Red River gets its name, as you can see by this picture, from the color of the silt and sediment it carries. So that is why it gets its name, Red River. So, whoops, I skipped one. So while the Palo Duro Canyon is much smaller than the Grand Canyon, it's still very beautiful and worth a visit. There's also lots of activities you can do there as well. All right, and then there's another picture of the beautiful red rocks. Boop. Okay, so if you want to know more about canyons, or you want to see more of the Grand Canyon for yourself, you can do a lot of stuff actually just online without even leaving your house. So if you go to the National Park Service website, nps.gov/GRCA for Grand Canyon, you will end up at this website. So let me show you. Get out of this presentation. Whoop. Okay. All right, here we go. We are at the park's website. So if you scoot down at virtual tours and ranger programs. So if you click this one, there's different field trips you can go on that have either like self-guided or actual lessons. And teachers, they also have, if your students do the lessons, they give them like a little completion certificate. So that could be fun. Then there's also virtual hikes, virtual raft trips, and other lessons that they offer, as well as videos, so you can see more about the Grand Canyon from the experts that work there at the national park. So I clicked this one because I wanted to show you a little bit how it works. So the virtual field trips, they have an unguided exploration, like I mentioned, where you can go around and use the imaging tools, and it's kind of like Google Earth. It gives you a 360 view. Then there's Mystery of the Blacktail Canyon that has a lesson. It stops at videos and shows you specific points. And again, layers and superpositions. So depending on what you're learning about and what you want to focus more on, they have different options. But I'm just going to show you the unguided just so you can see what I'm talking about. And no, this is not an ad for the Park Service. I am not being paid in any way. Okay, so like I said, it gives you like a 360 view. So if you are on the hunt for different landforms, you could definitely take screenshots and kind of go searching. So here we are, the Grand Canyon. And if you want to click different parts, it tells you different landmarks within the Grand Canyon. And like I said, you could go searching, looking around. It's pretty fun. I was playing with it for a while and I'm a grown up, so I was into it. So y'all should try it. Okay, anywho, Miss Ram, enough watching you play. All right, then I wanted to show you briefly a map of, sorry, the birds from that app are still going. Okay, so the maps of the national parks and also the state parks. So on the left, of course, is the map of the United States. And we have all these beautiful national parks that you can visit. So the Grand Canyon is over here. And then in Texas, we have the Carlsbad Caverns and Big Bend. Now, originally, they wanted Palo Duro to be a national park, but it is not. So now it is just a state park. And if you look on the right, there's the map of Texas with all the state parks marked off. And we have a lot that are actually nearby. So with Christmas break coming up or Thanksgiving break coming up, maybe you can get one of your grownups to take you to a state park near us. All right, that is all I have for you. I'm going to hand it over and I hope to see you next time.
Thank you, Ms. Ram. We did have a question. What is the largest canyon in the world? The Yarlung Sangpo Canyon in Tibet. The thing is 18,000 feet deep. It's a little bit longer than the Grand Canyon. Thank you again, Ms. Ram, for that very interesting and beautiful program. Now, Mr. Maris is going to tell us all about sand dunes.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about sand dunes and how they're formed. So before we get started, I do have an animal friend to show you guys. This animal friend happens to blend in perfectly with sand. So its scale color is about the same color as the sand. It has excellent camouflage. This animal also has 4 legs, a long tail, a beard of skin underneath his chin, They are native to Australia and it is an omnivore. If you've seen this before, you might have already met him. So go ahead and make your guess on what animal you think this is, and I'll go pull him out. If y'all guessed a bearded dragon, you would be correct. So this is Spike. He is a bearded dragon lizard. They get that name because they have that big pouch of skin underneath their chin. When they get scared or mad, they can inflate that beard really big. And then look at those scale color. He's almost the perfect color, same color as the sand. So he has excellent camouflage. So I'm going to go ahead and put our animal friend up and we will start our presentation. So today we're learning about sand dunes and how they're formed. So I'm going to share my screen with you guys and we'll take a look at a quick presentation. Hopefully by the end of this presentation, you guys will be able to answer these two questions. The first is, what is the main agent of change for sand dunes? And the second is, what are the processes that lead to the formation of sand dunes? And on this slide, you can see an example of what a sand dune looks like. You can see a little video of a man that is sand boarding. So just like you can snowboard, you can actually sandboard on those dunes. And here we have a wonderful picture of a camouflaged bearded dragon. So what we have here, I'm going to show you guys a video and I would like for y'all to make some observations. Think about what are some things that you observe or see and what are some things that you wonder. So you can actually do this experiment at home or at school. It's very easy. All you need is a box or a tray, a straw, and some sand. So think about what landform is being modeled in this experiment and also think about what is the force of nature or the agent that is being represented in this model. Also think about what is happening. Think about the movement of the sediment. So how is it moving and where is that sediment going? So hopefully as you guys were watching this video, you noticed that I was making sand dunes, hence the name of our topic today. So this is an example of how to create a sand dune. Now, the force of nature or the agent that's being represented is wind. So wind helps in the formation of sand dunes. And to create the wind, I am using the straw and I am blowing into it. So wind is a huge factor in the formation of sand dunes. So let's talk about exactly how they're formed. So let's take a look at the top picture first. The wind is blowing and it's carrying those tiny pieces of sand sediments. The direction from which the wind is blowing from is known as the windward side of the sand dune. As the wind is blowing, it's picking up those tiny pieces of sand and it's carrying them up the dune. Eventually, it gets to the top of the dune called the crest. Once it's at the top of the dune, it will continue moving. It will actually roll down the opposite side called the slip face. It's also known as the leeward side. Now, when those sand sediments are rolling down the opposite side, what force is pulling the sand down this opposite side? And I'll give you guys a hint. It's that same force that if you were to jump up, it's that force that is going to pull you back down to earth. This force starts with the letter G. So what do you think that is? Hopefully you guys said gravity. So gravity is the force that is pulling that sediment down the opposite side. So now let's take a look at the bottom picture and we'll use some of our science words. So we know that the windward side is the side from which the wind is blowing. Again, the wind is carrying those sand sediments. It is eroding them. So erode means to move. You might also hear the word erosion. So erosion is the movement of sediment. In this case, wind is eroding or moving that sediment. It eventually gets to the top of the dune called the crest. Gravity will pull it down the opposite end, and eventually the sand will stop moving and it will be deposited or dropped in a new location. You might also hear the word deposition. Deposition just means it's being dropped in a new location. So some of those processes involved with sand dune formation would be erosion, the movement, and deposition, the dropping of that sediment. So here's a quick little video. Scientists actually recreated the movement of those sand particles. This is sand moving in a wind tunnel. And that movement is actually called saltation. It's Latin for leap. So as the wind is blowing, it is lifting those small grains of sand off the ground. They eventually will drop or fall due to gravity. And when they hit the ground, they may jump due to the impact, and they may also hit the other grains of sand. So if you watch some of these sands, when it drops, it hits another grain of sand, and then that grain of sand ends up jumping or going up and getting caught by the wind. So again, that is saltation. So I thought that movement was pretty interesting. And there's different types of sand dunes. So take a moment to compare and contrast the different sand dunes that you see here on the graph. They are formed because of differences in a variety of factors, including things like wind speed, wind direction, the amount of sand that's available, as well as vegetation. So some of the ones that stood out for me was this one, the parabolic one. So notice out of all the other ones on this diagram, the parabolic one is near a water source and it has vegetation. This one also looked cool. This one's the star pattern for a sand dune. Notice that it has wind coming in from various directions, and that is what gives it that unique shape. And then let's take a look at this picture over here. Think about what type of sand dune do you think this one is? So compare it to the ones over here on the left, and also see if you can identify what direction is the wind blowing. So I have my cardinal point, so you guys can make a good hypothesis. What direction do you think the wind is blowing? And if you guys said the southeast direction, you would be correct. So remember, this is the windward side, and then the smaller side is the leeward side. And this one to me closely looks like maybe one of these Barkin type sand dunes. So it kind of has that parabola type shape, almost like a U. And just a quick review of some important vocabulary. So number one, wind can blank sand, moving it long distances. So what is the science word for when sediment is being moved? I'll give you a hint. It starts with the letter E. So hopefully you guys said erode. So again, erosion is just that movement. So number two, when the wind blanks or drops a lot of sand in one area, a sand dune forms. So again, what is that science word for when sediment is being dropped in a new location? And I'll give you a hint. It also starts with the letter D. So when the wind deposits or drops, remember deposition is the dropping of sediment. And the number three, true or false, the shapes of sand dunes are constantly changing. So to help you guys with this one, take a look at this little video here. Notice the wind direction on the windward side. Make some observations. What are you guys seeing? So we have the windward side and we have the leeward side. Hopefully you're noticing that, yes, that sand dune is moving. So over time, sand dunes will move and change. And again, that's due to a variety of factors, including the wind speed and direction and sand and vegetation as well. And if you are looking for a fun place to go on vacation, we actually have our very own sand dunes here in Texas. There's the Monahans Sand Hill State Park. If you ever go to El Paso, you probably go right through Odessa. So this state park is near Odessa, and here you can see a picture of two children. You can actually rent out these little sand boards, and you kind of just scoot and slide down those sand dunes. So that might be a fun vacation for you guys to explore. And I do have a challenge for you guys. Oops, let's see if my slide will go. So again, just to review, erosion is that movement of sediment, and deposition is the dropping of that sediment. So here's our challenge activity. Create your own sand dunes. All you need is a box or a tray, sand, and a straw. And just for fun, you can actually put a rock or maybe some grass or vegetation and see how that impacts the formation of your sand dune. So I'm going to stop my screen share, and that's all I have for you guys today on sand dunes. We're going to give it back to Dr. Gorman to answer any questions.
Thank you, Ms. Ramirez. Question came in. Where are the largest sand dunes found in the United States? The Great Sand Dunes National Park in Colorado. They have the tallest sand dunes of anybody in the United States. Now I am going to share my screen. During this virtual field trip, students explored the processes that led to the formation of sedimentary rocks and fossil fuels. Students also recognized how landforms are the results of changes to Earth's surfaces by wind, water, and ice. Formation of sedimentary rocks and fossil fuels by Mr. Dominguez. Mr. Monroe told you about deltas. Canyons was introduced by Ms. Schramm, and Mr. Maris just got through doing sand dunes. Thank you, teachers, for joining us. If you would go to www.tiny.cc/3-5 feedback. Fill out a very short form and send it back to us. We certainly would appreciate it. You guys have a great rest of the day, but more importantly, have a great rest of your life.